Hello and welcome. In this video, we are going to basically do the same thing, ray tracing, but we're going to look at ways of passing in data. Just before we go into that, I want to take stock of the start point that we are at. If we run this right now, of course, it does the same thing as it did in the previous video. I haven't touched that bit of the code yet, but what I have done is I've set up a sort of scene with a camera and a bunch of spheres. So if we take this from the top view, we have our project app, which has a state object. Basically, I can't call it scene because scene is a reserved word inside SwiftUI. That's a lot of fun. You get a lot of very cryptic errors there. But yeah, okay, so we have this state object, which gets passed as an environment object to the app view. And the app view basically takes that environment object and creates a content view. Now, content view has the environment object as well. It passes the environment object to the renderer class, and the renderer class is the class that will sort of be seeing that data and using that, or not using it for anything at the moment, just storing it in a variable, but it will read that data and send it to the shader, essentially. Now, what does the game scene actually have? If we go over to game scene, we have a single class, the camera, which is published, so it can be seen as from the environment object. And we create the camera here, and then we have a list of spheres. So we sort of create a whole bunch of random spheres with random positions, radii, and color, and those should be visible. Okay, so then how does a sphere work? Well, a sphere pretty much is a data container. It holds the data that we want to send to the shader for that particular sphere, and the camera pretty much is little more than a data container. So we have position and then some angles for looking around, and then the camera has the forwards, right, and up vectors. Remember, in the shader, the ray direction is a linear combination of forwards, right, and up. Anyway, we also have a routine here which calculates the forwards vector based on spherical coordinates, and then calculates the right and up vector based on cross products. So that's probably enough of an introduction. Let's get to the actual meat and bones of getting the data in. Okay, so let's modify this to get all of that data, those 32 spheres, into our shader program. Now, there are a number of ways to do this. The most simple way is simply to send the data off as bytes, sort of like we did with the light data, but there are some limitations. But anyway, let's go through this method. So one thing we're going to need is we're going to need to define a bunch of structs, but we've got an issue. See here, this struct is called sphere, and we have a sphere class, and that's going to cause a lot of confusion. So I'm going to preface this with shader, and I'm just going to set it up so that everything is prefaced with shader, just as a good practice. Okay, so we've got that. Now, that's all well and good. I'm also going to add a struct, which I'll use in my shader. I'll actually go ahead and write the full shader now, and then we'll just get the data in. And that is, we're going to need a render state. So we'll make that. So I'm being a little cautious here because I found that if I use bool, it will actually complain and say it doesn't have bool. Let's give it a second. Actually, let's compile and check. Yeah, unknown type name bool. So I had a look online and people were saying include standard bool. Yeah, annoying. So what I decided, my usual thing is just make it a float. I'd make it an int if I could, but shaders don't often handle ints so well, so for whatever reason, they handle floats. That's the same thing I'm doing with sphere count. Float just seems to be the simplest data type for a shader to handle. Okay, so we have that, and now I'm going to jump over to my shader. Oh, what are you complaining about? Oh, just complaining that the compile failed. Oh yeah, of course. Should stop talking to myself. So we'll have to jump in here and update everything. And I'm actually going to just go ahead and write the full shader function right now, just so we have it for later. Yeah, we can get rid of that. I was playing around with sphere marching. Turns out it's not good. It's too slow. Okay, where was I? So I guess I'm giving a little bit of the game away. This first approach, I'm going to define everything in bytes, sort of like with lights, we would say set fragment bytes. And in order to do that, we start working with pointers. And in order to have pointers, we need to specify address space. So this is going to be in constant address space. In other words, just something that the GPU can see. Okay. So, where was I? I'll leave that for now. Actually, no, I'll go ahead and write it. Okay, so I'm going to pass in a bunch of spheres, an array of spheres, so a pointer. I'm going to set that in at buffer 0. And I'm also going to put in the scene data. But that won't be an array, that'll just be a single thing. And that will be sent through buffer index 1. Okay, so we're just setting up our array based on the data. Now we could send the camera as a separate struct, that would totally make sense, but I'm going to sort of package it together. Doesn't matter so much. All right, so let's sort of clear this off, because we're not going to do that. Go call the ray color function. So we say, hey, I want to color based on my ray. Look into the scene data, grab the sphere count, and then pass along the pointer to the array of spheres, and yeah, does its thing. That will return a float 3, and so we'll write that out, adding the alpha component. Okay, cool. So that's all well and good. Now let's jump down, and the next one I want to look at. Next one we want to look at is the ray color function. Okay, so still nothing too exciting. All we are doing is we set up a color, it's black, it'll stay black if we don't hit anything, and then we just keep looping through, accessing the appropriate sphere, testing against it, and if we hit it, again, a little bit dodgy with the floating point checks, but hey, it's fine, it works. If we hit something, then we update our color. And really, I guess this might be a little bit of overkill, but as functions get more involved, this is the sort of structure that we'll go with. I'm just thinking that we can probably just update nearest hit and color. But anyway, that's fine. That's fine. All right, so now we'll go down to the hit function. Okay, cool. So we have sort of set this up to solve the quadratic equation. Now the solvability condition is that the discriminant is bigger than 0. So if the discriminant is bigger than 0, then we'll go ahead and solve that. So we'll solve for the value t, which we'd know from the quadratic formula is negative b plus or minus the square root. I'm going to go with minus because the plus or minus for a sphere would be the front face or the back face, and I want to get the front face. It would be closer to the ray. Let's go discriminant. So plus or minus that over 2a. There we have it. And if we're inside a sphere, of course, this will be a negative number, and that's not good. If we're inside a sphere, we don't want to render it. We don't want to get blocked, basically. So that's fine. So now we'll test if t is bigger than the minimum and less than . Yeah, I know, a little bit weird, but there it is. Okay, so if we get to the end here and we have not hit anything, then we want to simply indicate that we've not hit anything and return that. Okay, cool. So that's it. That's our ray tracer done. We just need to set things up. So like I said, I'm going to go with the simple version first, then I'm going to look at the more complicated version. So this simple version will work pretty much for anything up to about 1,000 numbers or so. So let's give that a go. We'll go to the renderer and down here in the draw function. So probably after we set the texture. Okay, cool. So what I'm doing is basically making a array and populating it with the structs, so we can then send that over. So if we send over the pointer to spheres, the length will be the number of bytes. So we go into the check the size of this, and that will be buffer index 0. Okay, all well and good. Now I'm also going to send a bit more. So I'm going to have That's fine. Oh, what's going on here? Oh yeah, we'll just cast that to a float. That's fine. Okay, and then we can set the bytes for that. Fingers crossed. Give that a go. There we have it. That's 32 spheres. We can check over, where are we? FPS is, oops. Jeez. I didn't want you to open like 10 things. Okay, where are we? There we go. FPS is 60. Memory is looking okay. Okay, yep, fair enough. So let's look at the limitations of this. I guess the issue is setting bytes. I believe it sends over one page. The page size on my Mac, I believe, is about 4 kilobytes. So it sends over about 4 kilobytes of data. So in theory, it shouldn't be able to handle more than that. So we can go to the game scene and just really dial up. So 1024 spheres, what happens there? It throws an error. So we can only send in so much data with this method. So the question is, what do we want to do to send in an arbitrary level of data? Many options. One that I use in my Python playlist is I just use images. So I just encode the data into an image as a texture and then send that over. But there are, well, the problem with that is it's a little bit annoying because I have to remember the way I've packed those bits together, the bytes, in order to unpack them. It's a little bit annoying. So a slightly better, more semantic way is shader storage buffer objects. They don't work on Python. They do work on Metal. And in Metal, shader storage buffer objects are basically buffers is what they're called. So unless I'm messing something up, but let's go with that. So if we go to the renderer, I'm going to make a function which will basically do the same thing. So I'll just comment this out. Okay, so I'm going to call this make sphere buffer. Okay, so what do we have? What we're doing here is, again, the same as before. We're just creating a whole bunch of them. And now we're populating an array of structs. Now I'm going to create a buffer. And at the point where I create it, I am sending over those bytes. We have length in bytes, a number of things that we're sending. Then we have options, and there's a bunch of these. We have storage mode shared is basically host visible. So the CPU can see it and the GPU can see it, and they both have sort of one copy that they can both see. We have private, which is only seen by the GPU. So if we want to send some data over to GPU memory, we sort of make a staging buffer. So we have a buffer that we can see and then encode a command to send that data over. I'm not going to do that. Then we have memoryless, and memoryless is memoryless is basically a temporary variable which only exists for the duration of a render pass. I'm not going to do that either. There's another one which I can't really see. It's called managed, and managed is where the CPU has a copy of the memory and the GPU has a copy of the memory, and you sort of manually synchronize operations between them. But anyway, I'm going to go with shared. That is the simplest. And I'm going to set that up. Okay, that's fine. And yeah, return that. So I'll just declare here I am returning. This is called a metal buffer. Okay, question mark. That's fine. All right, so all good. So down here, where are we? Go ahead and create this. We'll say unwrap the result, and then we go render encoder set buffer, and there we have it. The buffer we're going to set is our sphere buffer, offset of 0 bytes, and index of 0. Okay, so now what I need to do is I need to go back to my shader and give it a slightly different argument here. So where are we? Up here, we're taking the spheres. Now, if this is being passed in as a buffer, then that is const device memory space. Again, constant device memory space. So we can go in here and alter that. And that was ray color, so we're going to have to adjust that down here as well. But yeah, pretty much that's all we need to do. Now, if we run this, things get a little strange. So right now we can see it. If we just minimize that, bring it back up. Oh, it works. Okay. It's interesting. It wasn't working before. I'll go through how to, if this is not working for you, I was having issues where it would come up, I would minimize it, bring it back up, and it would look weird. So let's go to the game scene and dial up the number of spheres. This is horrible. You wouldn't do this, but just to check that it works. So it comes up. Yeah, it looks a little ugly. Let's move the camera back a little bit. Maybe 20 units back. Give that another shot. Okay. I mean, that looks reasonable. I'm curious. So its performance is tanking. Which side is it on? Oh, both sides. It would seem like. Anyway, that's fine. I mean, come on, mouse. Okay, sorry about that. It's got really laggy. So, there are sort of some issues with this, and it comes down essentially to memory alignment. So, for whatever reason, it's working now. It wasn't working before. If we look at definitions, we see that our sphere has sort of 3 and 1, so 4 and then 7. If we add in an extra float, then we have 8 bytes. So we can then go over to the renderer and it complains, and we can just set in come on, what do you mean? Oh, right. Whoops. You know what? It's sort of going okay at the moment. Yeah, okay. So sometimes that sort of like semi-fixes the issue, but before I was having issues where it was sort of flashing. I was getting more spheres on the screen, but it was flashing. So that doesn't quite fix it. What we do need to do, and I think this is the reason that it started working, is we need to align the layout. So this is going to be a little bit strange, but I'm going to make a pointer, then I'm going to align that to the page boundary, then I'm going to copy the memory over, flash it over to the buffer, and then free the pointer. So Okay, so it seems a little strange at the moment. Like I said, I'm working with a page size of 4 kilobytes on my device. So what this is doing is I am sort of starting at my... Yeah, I'm sort of taking this memory size, which might be any number of bytes or whatever, and I'm working out the padding that I would need to add in order to fill out those pages completely. Okay, so I'm just setting the memory alignment for the memory pointer, and then I can copy memory over to it. Okay, cool. So now when I create this, I can use the memory pointer, which now has a copy of all that sphere data. And for the length, I can go with allocation size. Okay, so if we run this right now, let's do it. Uh-oh. That's not good. Oh, okay, what have I done? Here we go. There we go. So we unwrap the pointer, and this bytes already sort of expects a pointer. So let's give that a shot. Okay, that's cool. But as you may see, over time, we have a memory leak. So this is sort of anyway, it's not good. So this is sort of an artificial example that I've sort of jimmied up. So we can sort of fix that by saying make that buffer first. This operation sort of gets that data over, and then free the memory, which is just a temporary variable that we used, and then return the buffer. And yeah, there we get the same thing, but without the memory leak. Fingers crossed, don't go up, don't go up. Yep, there we have it. Okay, cool. So yeah, I mean, this has just been an example of how to sort of get an arbitrary amount of data onto the GPU and get it in a format where we can read it. We don't have to unpack pixels like I was doing in my Python series. There we are. Hope you enjoyed this. I found it a lot of fun. Debugging, a lot of fun. And yeah, I'll see you again soon. Bye.